Hello students. So today I will be discussing about some modules, some topics related to Orthocenter. So it's basically a topic taught in the chapter Properties of Triangle. So we will be discussing about Orthocenter and some topics related to that. But prior to that, I want to revise the concept of sine law. So I hope most of you must be knowing what is sine law, but still let's revise. Just I will write the statement. So basic terminologies related to a triangle. In a triangle ABC, so this angle, it's called angle A, this is angle B, and this is angle C. Now opposite to angle A, the side BC, that is represented by small a. The length of BC, it is represented by small a. Opposite to angle B, the length AC is represented by small b, and opposite to angle C, the length of side AB is represented by small c. Now what the sine law basically states? It gives the ratio of the side to the sine of the angle opposite to that side. So I'm writing side A. Angle opposite to small a is capital A. So I'm writing down upon sine A. So what I'm saying that this ratio is always constant. B by sine B. Side B to the sine of the angle opposite to it. That B by sine B. And that is also equal to C by sine C. And which is equal to a constant K. That is equal to how much? 2R. Now what is this R? R is circumradius. R is circumradius of triangle ABC. So that's what is sine law. So by using sine law, we can easily replace the sides small a by 2R sine A. We can replace the side B by 2R sine B, and similarly C is equal to 2R sine C. So this is what is sine law. Now, after we have discussed about the sine law, we can now move on to our mainstream concepts, the one that we want to discuss today. So first and foremost, what is the orthocenter? So this is triangle ABC. Now what I am drawing, I am drawing the three altitudes of this triangle. So let the three altitudes be AP, BQ and CR. What is altitude? Altitude is a perpendicular dropped from vertex to the opposite side. So altitude AP, it's dropped, it is a perpendicular dropped from vertex A to the opposite side. So now, from our previous classes concepts, we know that the three altitudes of a triangle are always concurrent. That is the meet at a common point. And that point, we are saying, we are denoting that point by H. And this H is the orthocenter. This H is orthocenter of this triangle ABC. Now, what we intend to find, what is our purpose? We want to find the distance of orthocenter from the vertices and from the sides. So that is our first aim. We want to find AH, that is distance of orthocenter from vertex A. We want to find the value of HP, distance of orthocenter, perpendicular distance of orthocenter from the side BC. We want to find BH, and we want to find HQ. And similarly, we want to find what is CH and HR. So, we will begin our discussion, we will begin our analysis that how we can find these lengths. So so what we are going to do in this module is that we are going to find the value of AH and HR. These two lengths we are going to find. So if we can find AH and we can find HR, we can extend those results and we can generalize them, and we can find the value of CH, we can find the value of HP, we can find the value of BH and HQ. So let's begin our analysis of how we can find AH and HR. So observe, we'll make a fresh diagram. ABC is the triangle. AP is an altitude, this is 90 degree. BQ is another altitude, this is 90 degree. And CR is another altitude, so this is 90 degree. So what is our aim? We want to find AH and we want to find HR. Now, can you clearly see the triangle which is associated with these two sides, AH and HR? So both these sides are a part of the triangle AHR. So if we can successfully apply the sine law in this triangle AHR, we can easily find AH and HR. So before finding before applying the sine law, we must have a clear understanding of the angles. So what is this angle? Can we find this angle first and foremost? Yes, of course we can find. Now, clearly observe, triangle ABP. In triangle ABP. So this is 90 degree. And what is this angle? This total angle is angle B. And this is 90 degree. So what is this angle? Can you tell me? Can you observe? So angle BAP, that is what we are talking about. Angle BAP, this is angle B, this is 90 degree. So this must be 90 degree minus B. So now we have found out this angle. This is 90 degree minus angle B. So now this is 90 degree minus B. So what should this angle be? See, AHR, this is a right angle triangle. Triangle AHR is a right angle triangle in which this is 90 degree, this is 90 minus B. So what should be this angle? This angle is angle B, because see, right angle triangle, 90 degree, this is 90 minus B. So the remaining angle, it must be angle B. So now we will apply sine law in triangle AHR. So while applying sine law, we must have some idea about those sides and the angles. So do we know what is AH? No, we don't know. We want to find the value of AH. HR, also unknown to us. Now can we find the value of AR? Yes, of course we can find. You check. In triangle ARC. In triangle ARC we are talking about. So what is this total side length? We already discussed in sine law. So this side length is a small b. And this is 90 degree. Now in triangle ARC, this is 90 degree and this is B. And what is this total angle? This total angle is angle A. So now what is AR? Can you tell me what is AR? See, this is B and this is angle A. So it is B cos A. We can simply apply the formula of cos in triangle ARC and we can get that AR equal to B cos A. Again, B is 2R sine B, we can write cos A. So now we have found out that AR equal to 2R sine B cos A. We already know these two angles. This is angle B, this is 90 minus B. Now we will apply a sine law and we can easily find out the value of AH and HR. So we are applying sine law in triangle ARH. So what I am writing, see, AH upon the angle opposite to AH, which is equal to 90 degree. AH by sine 90 degree, that is equal to, see, this is how much? RH and this is AR. So we are writing AR. AR by the opposite to AR is how much? Angle B. So we are writing upon sine B and the remaining HR. HR upon sine of 90 minus B, the angle opposite to HR. Now we will clearly simplify this thing. What is sine 90 degree? Sine 90 equal to 1. So AH, that is equal to AR. The value of AR we have already found out. 2R sine B cos A upon sine B, and that is equal to HR, which is still unknown. Sine 90 minus theta is cos theta. So we'll write it down, cos B. Now sine B gets cancelled out. Let's equate this thing, these two, and we can get AH, which is distance of orthocenter H from the vertex A, and AH is equal to 2R cos A. And now we can also equate these two things, and we can find what is HR. HR means the distance of orthocenter from the side AB, and that is equal to how much? 2R cos A cos B. So now we have successfully found out AH and HR. These results we can generalize, and we can write the other values also. So how to generalize? Let's see. So now observe AH. AH means distance of orthocenter from vertex A, that is equal to 2R cos A. So from vertex A it is cos A. So from vertex B, instead of cos A, there will be cos B. So BH, the distance of orthocenter from vertex B, that will be 2R cos B. And CH, the distance of orthocenter from the vertex C, 2R cos C. So we have found out these three values. And now see HR. HR means distance of orthocenter from side AB, that is equal to 2R cos A cos B. So it was side AB, so they were cos A cos B. So now when we will be talking about side BC, it will be cos B cos C HP, distance of orthocenter from side BC. And similarly HQ, that is equal to how much? From side AC, so 2R cos A cos C. So this is some basic tips from which we can remember these three formulas. Okay, so these are the some very basic tips by which we can even remember the formulas easily. Okay, so now we can move on to our next module, that is about pedal triangle. That is another concept which is also associated with this orthocenter. So before understanding the concept of pedal triangle, so my request to you should be is that please try to remember this basic results, that is distance of orthocenter from vertices and sides. So now we'll be learning about pedal triangle. So what is this pedal triangle? Again, we'll start with drawing the three altitudes. Altitude AP, altitude PQ, and altitude CR. The three altitudes. So P is the foot of altitude AP on side BC. So try to understand what is P. The point P. P is the foot of altitude AP on side BC. Q is the foot of altitude BQ on side AC. So if we are joining these 3 foot, so the triangle thus obtained, that is triangle PQR, is the pedal triangle of triangle ABC. So we can just give a rough definition, that is the triangle obtained by joining the 3 foot of the perpendiculars, joining the 3 foot of the altitudes in a triangle is its pedal triangle. Now in this pedal triangle, our aim is to find the sides and the angles of the parallel triangle. So basically what we intend to find is that we want to find RQ, we want to find PR, and we want to find PQ. So let's find RQ, and we can generalize those results by the law of symmetry. So observe, how can we find this side RQ? Can we apply a sine law in triangle ARQ? In triangle ARQ, if we are applying the sine law, then what we will write? We will write RQ, opposite to angle RQ is how much? This angle is angle A. So we will write RQ by sine A, that is equal to AQ upon this angle. We don't know. We still don't know what is this angle. We still don't know what is this angle. So we will not go through that path. We will think of some alternate way. So RQ upon sine A, that is equal to 2 times circumradius of triangle ARQ by sine law, right? So what we will try to find, we will try to find the circumradius of triangle ARQ first of all. If we can find the circumradius of triangle ARQ, we can clearly equate RQ equal to 2 circumradius of triangle RQ into sine A. So how to find the circumradius of triangle ARQ? Now we have to observe carefully, and we can get a very beautiful result. So what is that very beautiful thing over here? Now observe this quadrilateral. Clearly observe the quadrilateral ARHQ. This quadrilateral ARHQ, if you observe, then you can just note and you can see something very important thing. What is that thing? Angle ARH is 90 degree plus angle AQH. It is also 90 degree. So both these 90 degrees sum up to 180 degree. So in this quadrilateral ARHQ, the opposite angles are supplementary. If angle R and angle Q sums up to 180 degree, then angle A and angle H will also sum up to 180 degree, because the sum of the all 4 angles will be 360 degree in a quadrilateral. So since the opposite angles are supplementary, so what is this quadrilateral? This quadrilateral, it is a special kind of quadrilateral. It is a cyclic quadrilateral. So basically, a circle can be drawn joining these 4 points ARHQ. Joining these 4 points, a circle can be drawn. And now let's make a fresh figure for the sake of understanding. So what we discussed till now is ABC, AP, BQ, CR, and this is H orthocenter. So we have discussed that these 4 points, they are concyclic, right? ARHQ is a cyclic quadrilateral, and we want to find the value of AQ. Now this is 90 degree, because altitude is 90 degree. So we already know a concept that angle in a semicircle is 90 degree. So for this circle ARHQ, this circle, can you figure out a diameter? Can you see a diameter over here? Yes, see, since ARH, this is a semicircle. Angle ARH, since angle ARH is equal to 90 degree. Similarly, this thing AQH is a semicircle. So these are the 2 semicircles separated by the diameter AH. So the diameter of this circle is equal to AH. And from our previous module, we already know this AH is equal to 2R cos A. Now, my question is, is this circle ARHQ, this circle whichever is drawn on this board, and the circle ARQ, are these two circles different or the same? These two circles are same, as because through three non-collinear points a unique circle can be drawn. We cannot draw two different circles or more circles which can pass through these three non-collinear points ARQ. So the circle which will pass through ARQ, it must also pass through AH. It must also pass through H. So the diameter of this circle, that is we have found out, equal to 2r cos A. And if I am writing down the radius of this circle, that is equal to the half of the diameter, that is equal to r cos A. And this radius is same as the circumradius of triangle ARQ. This triangle ARQ, that's what we wanted to find. So now what is the circumradius of triangle ARQ? That is equal to r cos A. Have you understood this analysis? This is a very simple analysis. That's what I have tried to explain you as clearly as possible. So the circumradius, that's what we have found out. Circumradius of triangle ARQ, that is equal to r cos A. Clearly we will write down, we will substitute this value in this equation, and we will write 2 times r cos A. So now what RQ comes out to be? 2r sine A cos A. 2 sine A cos A is equal to sine 2A, that is equal to r sine 2A. So we have found out one of the sides of this pedal triangle, that is equal to RQ. Now can we generalize these results and can we find the value of RP? Can we find the value of PQ? Of course we can find out the values. See how to generalize, I will explain. See the side RQ which is enclosing this angle A, for that I am writing r sine 2A. Now see, very simple observation. PR, it is enclosing angle B. So what is PR? That is equal to r sine 2B, correct? RQ was subtending, RQ was enclosing this angle, angle A. So we had written r sine 2A. Now PR, by symmetry, we can clearly write it in r sine 2B. And PQ, that is equal to r sine 2C. So these are the three results, the three sides. So we have successfully found the sides of the pedal triangle. Now I will try to make you explain that how to find the three angles in a pedal triangle.